What is the Permian extinction? Many would ask this question. The answer may astound you. It is actually the largest extinction known to man, with 95% of all species being wiped out and 97% of all organisms being wiped out. This extinction took place over 250 million years ago. The extinction has many theories, and I am here to educate you on them. So let's take a trip into the mind of the experts. Let's take an in-depth look into the Permian extinction. One of the most credible theories about the Permian extinction is the theory of Siberian traps. This was a giant section of Siberia covered in volcanoes that pumped carbon dioxide into the atmosphere, causing climate change. A professor of geology, Sam Boring, has studied this extinction for more than 12 years and has had some major insight into the scientific community. Professor Boring thinks he knows what happened with the Permian extinction, and this is what he thinks.
I've been working on the Permian extinction since about 1995. Puzzling extinction. I guess I tend to favor a very catastrophic perturbation of the environment, such as you might expect from the eruption of a very large igneous province, such as the Siberian traps. Yeah, that's my own personal feeling, but I don't, as of yet, really have any data that backs that up. Largest eruption that we know in the history of the planet. It's, depending on whose estimates you use, it's anywhere from 3 to 30 million cubic kilometers of lava erupted in a short period of time. So it has the potential to affect the entire planet. And one of the things that people have begun to realize is that as the lava moved up, it intruded large sedimentary basins that had coal, natural gas, and oil, and the potential is there for making huge amounts of gas, such as methane and CO2, by heating them with the lava.
Another large theory about the Permian extinction is that the ocean somehow became devoid of oxygen, or anoxic. This caused a large amount of carbon dioxide buildup in the oceans. This carbon dioxide made it into the atmosphere and caused extreme climate change. A professor at Smith College, Sarah Pruss, caused a commotion with this theory, and this is what she thinks.
So I think it's interesting. I mean, there's a bunch of pieces of evidence that are actually quite complementary to each other. I think there's really good evidence that anoxia was developing before the extinction and persisted through the extinction. So really low oxygen amounts, particularly in the deep ocean. Yeah. So that was one part of it. And then the other part of that is kind of the changes that happen from an ocean chemistry perspective as a function of that really deep water anoxia. And so that deep water anoxia may relate to surface water acidification. It may actually make it hard for organisms to make a skeleton. I mean, when you walk on the beach today, what do you see, right? All these shells that have nice, beautiful skeletons made out of carbonate. Well, what if that carbonate that they're using is hard to get? What if the saturation state of the ocean changes and it becomes really hard to make a shell? Then all of a sudden you're looking at a stress that could have lasted for a long period of time. The marine record and the land record look very different from each other. The extinction on land is much more consistent with climate change, which is what you would expect if you're injecting a lot of CO2, is that, you know, a lot of things that are adapted to cold climates go extinct, a lot of things migrate because things get too warm and stressful at the tropics, and so that kind of points to the fact that this is really fundamentally a marine extinction, and the way things happen on land is more consistent with climate change.
Now, all these theories have to do with climate change. So it seems that climate change is the most well thought out and acclaimed theory for extinction on land. Well, this may be true, the land is not the only part of the extinction. A professor of paleontology at Harvard University, Andy Knoll, knows a lot about the Permian extinction when it comes to land. And he has shown to be very helpful in learning about the extinction.
Any kind of volcanic event like this will put lots of gases into the atmosphere, both carbon dioxide and, because of burning plant material, methane as well. So far we have big volcanic event, lots of gases going into the atmosphere. There are then consequences of those gases. One is that it gets warmer, it's global warming. The second is that the oceans drop their pH, what we today call ocean acidification. And the third, because seawater will be warmer, it will be less able to carry oxygen and oxygenate the deep ocean. So we would expect to have oxygen depletion in subsurface parts of the ocean. And that's exactly what we see. We have geochemical evidence for all three of those things. So then the question you might ask is, if all of those are happening, what's actually responsible for the pattern of death and survival? Which of these killers was most important? What does the record actually say? And so we can actually look at the biology of the closest living relatives of organisms that lived in the late Permian and say, how tolerant should these organisms be of oxygen depletion? How tolerant should they be of temperature change? How tolerant should they be of ocean acidification? And what we find is that the one hypothesis that really fits the data is the idea of high CO2 and its direct physiological influence on organisms.
Even though these scientists have different theories, all these theories do seem to fit together in a sort of mega extinction plan, so to speak. It is actually quite simple if you think about it. I'll explain the way they fit together. The Siberian traps start out as the beginning of the massive extinction. As the ash and soot get into the oceans, the water begins to turn anoxic, which causes massive death underwater. As the carbon dioxide created by the anoxic oceans starts to get into the atmosphere, climate change begins and causes 70% of all land life to die out. The end result? Mass extinction. And whether this whole chain of events really happened will probably always be a mystery. But we can hope that at some point, if we can figure out what happened to those ancient creatures, maybe we can use that knowledge to help us understand our current climate crisis and maybe even find out how to fix it.
My baby don't mess around because she loves me so, and this I know for sure. But does she really wanna, but can't stand to see me walk out the door? I can't stand to fight the feeling, cause the thought alone is killing me right now. Thank God for Mom and Dad for sticking two together, cause we don't know how.